Okay, so in our previous exercise, we looked at how we can sketch some of these relations by plotting points. Okay, so if I was to just sketch this line here, okay, and we might call it y equals x plus 1. All right, so you won't know it just yet, but that's where the line goes through. Okay, so don't forget, that's my y-intercept or my y-axis, and that's my x-axis. All right, so we're now going to look at a couple of features of any straight line graph. Okay, and those features are the y-intercept and the gradient. All right, now let's start with the gradient. The gradient gives you an idea of the slope of the line. So you can see here the slope of the line is what we call the rise over the run. So that's how far across it goes, the run, and that's how far up it goes. So if we consider another line, maybe I might do it this way. Hopefully we can see that that line there is somewhat flatter. Okay, it's not as steep. So you can see that if I go the same distance across as I did with the first line, it doesn't rise anywhere near as much. Okay, so the steepness, or how much a line rises, is called the gradient of the line. Okay, and the gradient of that line is given to us by a rule called the rise over the run, which is the distance across, however many units. It might be 1 unit across, and it might be 1 unit up. Okay, it's probably not the best. So the gradient in this case would be 1, we put the rise, so 1 up over 1 across. All right. Whereas maybe just to make life a little bit simpler, what if we call the distance from here to be 2 units and the distance from there to there, I know it's not in ratio, it's not to scale, we'll call that 1 unit up. And so in this case, the gradient would be the 1 unit up over the 2 units across. All right, well, I'll explain that a bit better and a little bit more detail shortly. All right, so I guess the key part of it is understanding that each straight line graph has a gradient. Now, whether the gradient is 0 or what we call undefined, or whether it's 1 or 2 or -3, it's got a gradient. Couple of special gradients. If the slope of my line is 0, in other words, it's a flat line. So let's come over here. If it's a flat line, it means there is 0 up. It doesn't go up at all. And so that sort of line has a gradient of 0. All right. If we have a vertical line, okay, well, we say that the gradient of that line is undefined or infinite because it rises indefinitely. You know, there's no limit as to how much it rises, and it goes across 0. All right, so there's 2 special lines that we need to remember. Keep moving my thing, leave that. So an infinite gradient or an undefined gradient is a vertical line. A 0 gradient is a horizontal line. All right. Now, the other 2 key pieces of information, if my graph slopes upwards, so as I go from left to right, the direction that we read and count, and my line is increasing, it's a positive gradient. If as I go from left to right, my line heads downwards, it's a negative gradient. All right, so there's sort of 3 or 4 key features there. The slope of the line is the gradient. We can have a 0 gradient or an infinite gradient, or we can have a positive gradient or a negative gradient. Okay. The other key feature is called the Y-intercept. Now, an intercept, if you think about the word intercept, it's where some things cross or intersect, they meet. And so the Y-intercept if we come across, is where my line crosses the y-axis. Okay, so wherever we are, if I've got that green line going down my vertical axis, wherever I am on that axis and my line crosses it, that's called the y-intercept. All right, and so the coordinate of that y-intercept, so for example, I think I said that point there on my graph is at x equal to 1, sorry, at y equal to 1. So the coordinate of that intercept is 0 across, 0 left or right, and 1 unit up, okay, which is what we've got here, okay. So there's my y-intercept and my gradient. Now, the good thing is there's a few different parts to this. The nice thing initially is it's really easy to identify what the y-intercept and the gradient are from the equation of the line that we've been given. Okay, so if we come down to example 4, all right, we can see that we've been told for any straight line graph, if y equals mx plus c, the coefficient of x, we studied coefficients in algebra a unit ago, is the gradient, and the constant is the y-intercept. So if I just do a quick example, y equals, I don't know, negative 3x plus 4, the gradient is the number in front of the x, so the gradient of this line is negative 3, and the y-intercept of this line is 4. Okay, we'll work through these other values first. All right, so let's have a look at this example. State the gradient and the y-intercept for each of the following. So m, the number in front of the x, is 2. The y-intercept is the constant at the end, so I can put 1 or positive 1. Okay, again, the number in front of the x. Now we can see a negative sign there. Remember, if there's not a number in front of a pronumeral, it means the number is 1. There's one of them. So in actual fact, the number in front of the x is negative 1. The constant at the end, positive 3. Finally, the number in front of the x is positive 3, so m is equal to 3. And the y-intercept is a constant at the end, which in this case is negative 1. All right, so they're relatively straightforward to read off the graph. So finding them is nice, making use of them, well, that's the understanding part of it. Stay in here for a minute. Let's just do a quick graph sketch. Let's talk about how each of these, do you want to sketch it yet? No, we won't. All right, so actually, okay, let's do one other example, okay? Find the gradient and the y-intercept for each of the following graphs. So let's talk about the y-intercept first, because I think that's the easiest one. So remember we said about the y-intercept. The y-intercept is whereabouts the line crosses the y-axis, which is that point there. Well, should I use blue? I'll use black. So that point there is where the line crosses the y-intercept there at negative 2. So the y-intercept is negative 2. Yeah. So again, look down the vertical axis until we cross it. Oh, it's negative 2 again. So y-intercept, negative 2. Example 3, let's go down the axis until we cross it. There's the y-intercept there, and that's at positive 1. So the y-intercept is positive 1. Okay. Now, the next part is to try and find the gradient. And we can find the gradient as long as by making any triangle. And we try to make the triangle intersect at points that give me nice whole numbers. So I'm going to pick, I'll show you 2 different ways. All right. I'm going to start at that point there at negative 2. And I've got a point up there at 2. So if I draw this triangle here, okay, I now just want to work out how high my triangle is, the rise, and how far across it's gone across. So if I think at the run, so remember, we'll call that the run. You make this a bit bigger. There's the run. Just rub that out. So the run, I've gone across 1, 2, 3, 4 units. If I want to get the rise, I've gone up 1, 2, 3, 4 units. And so in fact, I might change the color of that. And the rise is equal to 4. So coming in here, the gradient M is equal to the rise over the run. So I've run across 4 units to the right. Oops, wrong color. So I've gone 4 units to the right with the run. And now I've gone 4 units up with the rise. So if I simplify that, I get an answer of 1. Okay. Let's go across and do the other one now. B. So again, actually, I'll stay here. I could have done any triangle. We can see a triangle that they've drawn here already. We can see that they've gone across 2 units to the right, and we've gone up 2 units. Again, 2 over 2 is also 1. I could have drawn a different triangle here. There. How far across is it? I've gone 1, 2 across, and I've gone 2 up, and again 2 over 2 is 1. So it doesn't matter where I draw my triangle. The idea is to pick a triangle that gives me some nice values to work with. All right, we don't want to come up with fractions or things like that. All right, so again, I'm going to just find any triangle anywhere. In fact, what about these points here? I'll go down in blue, across in pink. Okay, so if I'm starting with my rise, I start at my point, and this time I'm going to go 1, 2 units to there, but I've gone in the negative direction. Okay, and from there I've gone 1, 2 units up in the positive direction. Oh, I should use a different color. So we're going to say have the run here, which is -2, and I've got the rise here, which is +2. So again, I get 2 over -2, which equals -1. So remember what we said, okay? If you're not too sure about the sign, if I draw on my line as I go from left to right and I go up, it's a positive gradient. If I draw on my line from left to right and I head down, it's a negative gradient. And so we can see the different signs or the different directions those two lines slope. So we should have opposite signs. All right, let's go to number 3. I'll go across in green. So there's a nice, so I could pick that point there, but see it's in the middle of -1 and 2. So it's going to give me a messy number. So I'm going to pick some nice spots, that point there, and I might go from there up to where it is at 3. So there's my triangle. All right, so again, in blue across, how far? I've gone 1, 2, 3, so the run is 3. So I started from the left and worked to the right 3 units. And now I'm going to start from the bottom, and I'm going to go 1, 2, 3, 4, 5, 6 units up. And the rise is 6. So now gradient is rise over run, which is 6 over 3, which will give me an answer of 2. Okay, so let's compare. So I've got a gradient there of 2, +2, which compared to the gradient of +1 looks more steeper. Is that a proper English? Which looks steeper. So that's a good sign. And they're clearly in the opposite direction to the second graph, which means one should be positive and the other one should be negative. Okay, so the final part of this says, okay, write the rule now for each of these equations. So remembering from the previous notes that y equals mx plus c, I can say that y is equal to m, and in this case, m is equal to 1, x, and then the y-intercept is minus 2. So in other words, y is equal to x minus 2. If we go to the next graph, we know that y is equal to mx plus c. So the gradient in this case was negative 1. So I'm going to put a negative 1 there, times x plus c, which is minus 2. So we can say the rule is equal to minus x minus 2. Finally, again, y is equal to mx plus c. So the m value in this case was positive 2. The c value is plus 1. So in this case, y is equal to 2x plus 1. All right, so there's a little bit in there. So stop, maybe have another listen to the video, and then go on and try some of the questions.